Hello educators and future CTET champions. Welcome back to the Crack the CTET Math section series where we deal with the real CTET questions and build your concept clarity step by step. Today we are diving into a very foundational yet oft feared topic, which is fractions. Yes, those little numbers which sit above and below a line and makes the whole paper look much more complicated than it is. But not after today. This video is part 3 out of 6 of my series called Crack the CTET Math section, which is mainly for paper 1 students. But if your maths basics are weak, this also caters to the paper 2 math science students. If you're a paper 2 social science student, then maths is not for you. You will not be tested on maths. So let me recommend to you one more of my playlist, which is called Crack the CTET Language Section. I'm sure you'll find that very helpful. In the previous 2 videos of this series, in video 1, I have looked at the overview of the maths structure and how I divide it into 3 sections and not 2, so that even if your maths is weak, you can definitely focus on 2 out of those 3 sections and ensure that even if your solving of maths is a little weak, you can crack the maths section. This is the process that I teach in my CTET Success Blueprint, and you can check them out on my website www.lwsctet.com. In video 2 of this playlist, I had looked in depth into the metric system. If these videos have been helpful, it would be great if you could drop in a like and share these videos with teachers who would need it. It would be lovely if you could subscribe or drop in a comment. Hi, I'm Dr. Swasti Dhar and I mentor teachers and trainee teachers to crack the CTET exam in their first attempt through my self-paced online courses, which are available on my website www.lwsctet.com. You can purchase these courses anytime and study at your own pace. And 3 to 4 months before the next upcoming exam, we get together for weekly classes where I clear your doubts, and also once a week we meet to solve PYPs. For the upcoming July 2025 CTET, the classes have already begun. But if you are looking forward to the December CTET, then do join my CTET preparation WhatsApp group. The link will be there in the description. Let's begin. So let's understand the concept of fractions. The basic concepts that you need to teach in school and even to do sum. So the first concept that you must remember is that a fraction is less than 1. It lies between 0 and 1. Now, mathematically, we do write it as proper fractions, improper fractions, and mixed fractions, and I will explain that. But the concept of a fraction is that it lies between 0 and 1. For example, if there is a rupee, then maybe half a rupee or 1/4 of a rupee. Those are fractions. Then we'll talk about the concept of equivalent fractions. This is required for you to do ascending, descending, those sums, and we'll talk about like fractions. What are like fractions, so that you can do your addition, subtraction. So any fraction has 2 things, a numerator and a denominator. It is generally written like this. So the number on top is called the numerator, number at the bottom is denominator. For example, 3/5, 6/7. These are all fractions. Now whenever the denominator is greater than the numerator, this is called a proper fraction. But if the denominator is less than the numerator, for example, 8/5, 6/3, then these are improper fractions. These are not fractions at all, but mathematically, these are written in the fraction form. So these are called improper fractions mathematically. Improper fractions are also written as mixed numbers, which has one whole number and a fraction. For example, 8/5, what we will do is we will divide 8 by 5. We get 5 ones are 5, and we have a remainder of 3. So this number will be written as 1/3/5. So to recap, a proper fraction will have the numerator which is smaller than the denominator. For example, 2/5, 3/6, 1/4, 9/16. These are all proper fractions. Mathematically, we can also have improper fractions where the numerator is greater than the denominator. So 6/3, 5/2, 4/1, 16/9. These are all improper fractions. And generally, improper fractions are written as mixed numbers. The numerator is taken and divided by the denominator. So this will become 6. Since there is no remainder, it will be a full number 2. But if I take this 5/2, if I divide 5/2, then 2 2s are 4. I have a remainder of 1. So this 2, this quotient is the whole number. The remainder is written on top as a numerator, and this, which is called the divisor, which was the original denominator, this becomes the new denominator also. So 2, 1/2. So these are mixed fractions. In order to add or subtract any fraction, we have to understand the concept of like fractions. Like fractions are those whose denominator is the same. So let me take one example. Let's say I have to add 1/3 plus 2/3. So step 1, I will look at the denominators. They are the same. So I can write the denominator once because both are the same. and I will just add the numerator. So this becomes 1 plus 2 or 3 by 3, which is 1. But if I take another example, let's say I have 1 by 6 and I want to add 1 plus 5. Step 1, look at the denominators. They are not the same. So step 2 is you have to get such a number that the denominator becomes. How do we do this? So we do this by forming equivalent fractions, which says that if you multiply or divide both the numerator and the denominator by the same number, then the fraction remains the same, which means, let's say I have 1 by 3 and I multiplied with both the numerator and the denominator with the same number. So 1 into 2 is 2 and 3 into 2 is 6. Then 1 by 3 is equivalent to 2 by 6. Visually, it can be shown like this. Let's say there's a strip of paper. This is how we do it in class. And the first one, I divided into 3 parts and I shade 1/3 of it. This is 1 by 3. Now, the next one I can divide into 6 parts and I shade 2 by 6. Both of them are equivalent. So this is the concept of an equivalent fraction. Why are we using equivalent fractions? Because we want to make like fractions. What had I said about like fractions? They are two fractions with the same denominator. So let's go back to our sum. We wish to add 1 by 6 and 1 by 5. So what we have to do is we have to convert both 1 by 6 and 1 by 5 into such a fraction that their denominators are the same. How do we do that? Generally, it is done by finding the LCM. So the LCM of 6 and 5 is 30 because 6 is a factor of 30 and 5 is a factor of 30. So now let's convert them into equivalent fractions. We have to multiply 6 with 5 to get 30 and we have to multiply 5 with 6 to get 30. So if we multiply the numerators with the same numbers, we will get equivalent fractions and then only can we add them. So this becomes 5 over 30 and we have to add 6 over 30. We have rewritten 1/6 as 5 by 30 and we have written 1/5 as 6 by 30. This is what we have done. And now because they have become like fractions, we can add the numerators. So this becomes 11 by 30. So let's do a flow chart. When you are given a fraction, check whether the denominators are the same. If they are the same, then just add the numerators and divide by the denominator, which is the same number. But if it's a no, then you have to make them into equivalent fractions, equivalent like fractions, and then you do the addition and subtraction. So let's see the sum which was given on addition and subtraction. We have 4 over 7, we have to add 5 over 14, and we have to subtract 7 over 8. So we first look at the denominators. Are they the same? No. Can we find a number which will make them equivalent, but we want them to be the same number? So we want like fractions. So we have to find the LCM of 7, 14 and 8. If we do the prime factorization, we start with 7, this is 1, this is 2, this is 8, 2, this is 1, 1 and 4. So the LCM is 7 into 2 into 2 into 2. 2 to the 4, 4 to the 8. So 7 into 8, 56 is the LCM. So now we have to make each of them into like fractions. So 4 over 7 becomes, we have to multiply this by 8, so both by 8. So 32 by 56. Let's just first make it into equivalent fractions. 14 fours are 56. So we have to multiply, if we take 5 by 14, we have to multiply both with 4. So this becomes 20 over 56. And if we take the third one, which is 7 over 8, we have to multiply this with 8 sevens are 56. So it's 49 by 56. So the three equivalent fractions are 32 by 56, 20 by 56, 49 by 56. So basically, if we write the denominator as 56, we have 32 plus 20 minus 49, which is 52 minus 49 or 3 by 56. So this is the answer because you cannot simplify this further. So that was about addition and subtraction. Let's learn a very simple thing about multiplication and division of fractions. If we are given two numbers, say 3 by 56 and 7 by 8, for multiplication and division, first let's learn multiplication, then you can learn division. For multiplication, you basically have to just multiply the two numerators and multiply the denominators and put it down. So ideally, like when we first teach beginners, this will be 3 into 7 over 56 into 8. And then you just do the multiplication. So 21 by 448. However, what we do is called simplification. When we are doing simplification, you can divide any numerator or denominator with the same number. So like for example, 7 can be divided by 7, we get 1. 56 can also be divided by 7, we get 8. So now it leaves us with 3 into 1 and 8 into 8. which is 3 by 64. Now you will say, what is this? Let's say we can divide both by 7. So 7 3s are 21 and 7 6 are 42, 4s are 28. So 3 by 64, we get the same number. How does one do division? It's very simple. If you have been given a by b and you're asked to divide it with another fraction c by d, then you simply write a by b, you write the multiplication sign, you change this into multiplication sign, and you reverse this. Inversing it is called. So this becomes d by c. So instead of dividing with c by d, we multiply with d by c. So if we have 64 by 8 to be divided by 1 by 2, then we just make this 64 by 8. The first number remains the same. We write multiplication sign and we make this 2 by 1. Now for simplification, this goes 4 times and this will go 4 times, 32. So the answer is 32. So this part is simplifying, mainly is getting this fractions correct. In January, we were asked a simple question of division. How many packets of 1 by 12 kgs can be made from 7.5 kgs of salt? So basically, if we have 7.5 kgs of salt, then how many packets of 1 by 12 kgs can we make? So we have to take 7.5 kgs and divide it by 1 by 12. So 7.5 has to be divided by 1 by 12. How do we do this? First, we make this into an improper fraction. 7 2s are 14 plus 1, 15 by 2. So 15 by 2 has to be divided by 1 by 12. What do? We write 15 by 2. We make this into a multiplication sign and we make this 12 by 1. And then we simply do the simplification. So 15 into 6 is 90. So 90 bags can be made. So this is how addition, subtraction, multiplication, division of fractions is used. Basically, the sum will be given and you have to figure out how to add, subtract, multiply, divide fractions. Let's now move on to the very dreaded question of ascending, descending, and for that we will use the concept of equivalent fraction. In order to answer questions like this, put them in ascending order, put anything in descending order, we have to make them into equivalent like fractions. So let's find the LCM of 4, 3 and 2. We do it by the prime factorization method. So 3 into 2 into 2, 3 2s are 6, 6 2s are 12. So 12 is a number which we can convert all of them. So 1/4 becomes 3 by 12 because 4 3s are 12. 1/3 becomes 4 by 12 and half becomes 6 by 12. So we are basically comparing 3 by 12, 4 by 12 and 6 by 12. You have been asked to put them in ascending order, that is smallest to biggest. So 3 by 12 is the smallest, 4 by 12 is the next, 6 by 12 is the biggest number. If the denominators are the same, then you just look at the numerator. So 3, 4 and 6. So 1/4, 1/3 and 6 is already in the ascending order. There was one more question like this. Let's do that. It was asked in July 2024. Put these in decreasing order. So let's first find the LCM. We have to find the LCM of the denominators. So it's 9, 21, 7 and 63. Let's start with 7. This goes 3 times, this goes 1 time, this goes 9 times. Then we do and 3 again, and we get 1 all over. The LCM is 7 into 3 into 3 or 7 into 9, which is 63. So let's make all of them into equivalent fractions. 1 by 9 can be now written as 9 7s are 63. So this becomes 7 by 63. 1 by 21 becomes 3 by 63 because 21 into 3 is 63. 3 by 7, 7 9s are 63. So 9 into 3 is 27. 27 by 63. We have multiplied both of them with 9. And the final one is 12 by 63. So 63 is only going to be multiplied with 1. So this is 12 by 63. Now that the denominators are the same, we only have to look at the numerators. So let's put it in decreasing order, which will be the biggest number. Biggest number is 27, which means the fraction is 3 by 7. The second biggest number is 12, which means the fraction is 12 by 63. The third biggest number is 7, which means the fraction is 1 by 9. And the smallest number is 3, which means the fraction is 1 by 21. So this becomes the decreasing order. Let's find the answer. Yeah, this is the answer. That leaves us with 2 pedagogical questions which was asked. Let's look at those also. And if you have any comments, do put it in the comments below and ask me more questions, whichever you find confusing. So the first pedagogical question was asked in August 2023, which says, which of the following is the most appropriate way to help a primary school learner visualize the equivalence between 2 by 3 and 4 by 6. So the best way is using fraction discs. Fraction discs are discs of which can be broken into fractions. So this is a fraction disc. You have these plastic things which they can break into half, so they know that this is a half. There are more like this they have put together, but there would be a circle in which it is broken into 8 parts, and the child can keep breaking it and seeing that this is 1/8, and 2 of 1/8 will become 1/4. So fraction discs are very, very good to teach fractions. The other thing which is used in schools actually is paper. They use paper folding. So they will take a paper, fold it into half, and explain that this is 1/2 and this is 1/2. And this can be broken again into or folded into half. This becomes 1/4 by 1/4. So fraction disc and paper foldings are the best way to teach fractions. So out here, fraction disc would be the correct answer. We can't use calculators. LCM, they should know, but this is taught later. At the primary level, we should use fraction disc. Another option would have been paper foldings. Here's the second question. A child solved a problem of 1/2 plus 1/3 is equal to 2/5. What is the most appropriate inference? So basically what the child has done is 1/2 plus 1/3. He has just added the numerators. 1 plus 1 is 2, and he has added the denominators, which is 2/5. So he does not know the concept of like fractions. The fact that he has to find the LCM of this and make the 6 and all that. So what is the inference? He does not know how to represent fractions on a number line? No. He has extended the concept of addition of natural numbers to addition of fractions? Yes, this is what he has done. He does not know addition of numbers. Numbers we don't know. He does know how addition of numbers. Fractions he has not learned to add. And he does not know how to take LCM. We are not sure about this. Maybe he has just extended it. So what we can definitely say is the child has just extended the concept of addition of natural numbers into fractions. So I hope that was helpful. Fractions is actually very simple. If you just go through it step by step, practice a bit, ensure that you can add and subtract, and understand the concepts and do lots of practice, which is what I do in my Math Success Blueprint, which is a part of my CTET Success Blueprint. Fractions will not be scary anymore. Thank you for watching this video. If there were any other questions you would like to ask me, do put it in the comments below, like this video, and you can be a part of the CTET WhatsApp preparation group. The link is put in the description. Thank you.